Hello, my name is Torstein Tengs. I work as a scientist at the Veterinary Institute in Norway, and I work on work package 6, part of the Co-Explore project. The work package 6 is concerns technical challenges in detecting GMOs. And basically, when you want to check a sample for the content of genetically modified material, you can use various different approaches. And in our work package with our partners, we have explored various molecular methods. So instead of looking for the genetically modified organisms directly, we look for their DNA. So when you want to do that, there are some technical challenges. You want to be able to detect many things at once. That would be nice. You want to be able to detect things that are in low abundancy, and you want to be able to detect things without making any assumptions about what you're looking for. So we can call these things multiplexing and unknown GMOs, and there are various subgroups of tasks within the work package. So in the work package we have explored various technical tools that have been developed in other aspects of science. So we have taken concepts that have been developed elsewhere, and also we've developed some of our own, and then tried to see how well they work in GMO research. So primarily we focus on those three things: looking at many things, looking at rare things, and looking at unknown things. Many different methods have been developed, and some of the methods will enable researchers to do things a lot more efficiently and cheaper and less labor intensive. And we are in the process of developing tools that should be quite useful for stakeholders and people that want to see the practical implications of the work done. An example is a microarray-based detection system that's commercially available, and it was developed by Eppendorf array technology. It's called a dual chip or GMO chip. It's a fairly simple system that will allow you to screen for many different genetically modified organism markers and specific markers that will identify a particular type of organism immediately at once. So it's a high throughput, fairly easy to use tool that is commercially available and has already been validated. In addition, there are a lot of tools that are currently being developed and refined as research tools, and hopefully some of these will turn into commercially available products. They seem promising, and a lot of the partners have done a really good job of exploring the concepts that they set out to do, but getting something commercially useful might take a little bit more time. So for now we have a lot of good results and a lot of scientific publications that hopefully people can build on in the future. And our goal is, of course, to help the screening and testing of samples so that people know what kind of products they're getting. And throughout the supply chain there are various time points and sampling points where you can imagine that our tools can be used to make sure that the user, the consumer at the end, will have a product that has been thoroughly screened, and that if you are a stakeholder, you do importing, exporting of products, you have the tools necessary to check the products that you are distributing. So another important thing is that there seems to be a higher number of unknown genetic modifications popping up around the world, and that's mainly due to the fact that it has now become not simple, but it's getting easier to generate genetically modified organisms. You don't necessarily need a big institute with highly skilled technicians. You can actually go online on the internet and find protocols on how to do this. So there is a fair chance that people will be developing genetically modified organisms and possibly releasing them in the environment, or they will enter the food chain somehow unchecked, and that's of course something we should be a little bit concerned about and aware of. So one of the other technical challenges has been to develop tools that can be used when you don't really know what you're looking for. If you have some sample and you suspect that it's not what it's labeled as, or it's not really what we call wild type material, then you want to be able to screen and check and see if somebody has done any changes to the genetic code of that material. So if it's a genetically modified organism, you want to be able to figure it out. And what kind of genetic modification, risk assessments associated with it, labeling regulations, is it approved, unapproved, can it potentially be something that can spread in the environment to other plants, for instance. All these things are very important in a situation where somebody is generating genetically modified organisms in a way that's not controlled according to the regulations. So we have developed several very interesting tools to do this, and they will require that you have a fair amount of resources to put into each sample, the way the methods work now, but they're primarily research tools currently, but hopefully in the future, if you could make production cheaper and also maybe increase throughput using the strategies that the methods rely on, they might be useful for high throughput screening also. But it's very challenging because when you don't know what you look for, it's difficult to come up with good detection methods. So that's going to be another very interesting aspect of GMO research in general, seeing how these methods can be refined and how they can tackle the real-life situations we are probably going to have, whether we want to or not, with GMOs that have not been thoroughly risk assessed and characterized being released in the food chain or in the environment.